In early February, first Google, then Microsoft, announced major overhauls to their search engines. Both tech giants have spent big on building or buying generative AI tools, which use large language models to understand and respond to complex questions. Now they are trying to integrate them into search, hoping they'll give users a richer, more accurate experience. The Chinese search company Baidu has announced it will follow suit. But the excitement over these new tools could be concealing a dirty secret. The race to build high-performance, AI-powered search engines is likely to require a dramatic rise in computing power, and with it a massive increase in the amount of energy that tech companies require and the amount of carbon they emit. There are already huge resources involved in indexing and searching internet content, but the incorporation of AI requires a different kind of firepower, says Alan Woodward, professor of cybersecurity at the University of Surrey in the UK. It requires processing power as well as storage and efficient search. Every time we see a step change in online processing, we see significant increases in the power and cooling resources required by large processing centers. I think this could be such a step. Training large language models, LLMs, such as those that underpin OpenAI's ChatGPT, which will power Microsoft's souped-up Bing search engine, and Google's equivalent, Bard, means parsing and computing linkages within massive volumes of data, which is why they have tended to be developed by companies with sizable resources. Training these models takes a huge amount of computational power, says Carlos Gomez Rodriguez, a computer scientist at the University of Coruña in Spain. Right now, only the big tech companies can train them. While neither OpenAI nor Google have said what the computing cost of their products is, third-party analysis by researchers estimates that the training of GPT-3, which ChatGPT is partly based on, consumed 1,287 megawatt-hours, and led to emissions of more than 550 tons of carbon dioxide equivalent, the same amount as a single person taking 550 round trips between New York and San Francisco. It's not that bad, but then you have to take into account the fact that, not only do you have to train it, but you have to execute it and serve millions of users, Gomez Rodriguez says. There's also a big difference between utilizing ChatGPT, which investment bank UBS estimates has 13 million users a day, as a standalone product, and integrating it into Bing, which handles 500 million searches every day. Martin Bouchard, co-founder of Canadian data center company Scale, believes that, based on his reading of Microsoft and Google's plans for search, adding generative AI to the process will require at least 4 or 5 times more computing per search at a minimum. He points out that ChatGPT currently stops its understanding of the world in late 2021, as part of an attempt to cut down on the computing requirements. In order to meet the requirements of search engine users, that will have to change. If they're going to retrain the model often and add more parameters and stuff, it's a totally different scale of things, he says. That is going to require a significant investment in hardware. Current data centers and the infrastructure we have in place will not be able to cope with the race of generative AI, Bouchard says. It's too much. Data centers already account for around 1% of the world's greenhouse gas emissions, according to the International Energy Agency. That is expected to rise as demand for cloud computing increases, but the companies running search have promised to reduce their net contribution to global heating. It's definitely not as bad as transportation or the textile industry, Gomez Rodriguez says. But AI can be a significant contributor to emissions. Microsoft has committed to becoming carbon negative by 2050. The company intends to buy 1.5 million metric tons worth of carbon credits this year. Google has committed to achieving net zero emissions across its operations and value chain by 2030. OpenAI and Microsoft did not respond to requests for comment. The environmental footprint and energy cost of integrating AI into search could be reduced by moving data centers onto cleaner energy sources, and by redesigning neural networks to become more efficient, reducing the so-called inference time, the amount of computing power required for an algorithm to work on new data. We have to work on how to reduce the inference time required for such big models, says Nafees Sadat Mousavi, a lecturer in natural language processing at the University of Sheffield, who works on sustainability in natural language processing. Now is a good time to focus on the efficiency aspect. Google spokesperson Jane Park tells Wired that Google was initially releasing a version of Bard that was powered by a lighter-weight large language model. We have also published research detailing the energy costs of state-of-the-art language models, including an earlier and larger version of LaMDA, says Park. Our findings show that combining efficient models, processors, and data centers with clean energy sources can reduce the carbon footprint of a machine learning system by as much as 1,000 times. The question is whether it's worth all the additional computing power and hassle for what could be, in the case of Google at least, minor gains in search accuracy. But Musavi says that, while it's important to focus on the amount of energy and carbon being generated by LLMs, there is a need for some perspective. It's great that this actually works for end users, she says. Because previous large language models weren't accessible for everybody.